I will take the direction that the axis is pointing in and with its letter labeled as positive. So that's positive x, that's positive y, that's positive z. And hence, that point there is 1, -1, 0. I believe. Likewise here. So that point there is 4, 4, -4, 2. And here, -1, 2. -1, 2, 2. And here, -2, -4, 2. And to plot each point now. Taking these again to be positive, by convention. Nourish. Direct and inverse proportion next. Direct and inverse variation, as they term it. This here is an inverse variation. As you can put it in the form y equals 15 over x. And the general form of an inverse variation is y equals k over x. Likewise, an inverse. Another inverse. But this is a direct variation. Here y equals 5x by rearrangement, and this is a direct variation. And lastly, a direct variation. All direct variations ultimately have a form of y equals kx, where k is a real number of some kind. In this case, 3 is known as the constant of variation. Putting it in the standard form like that, y equals 7 over x, 7 is the constant of variation. Y equals 5x here, so 5 is the constant of variation, and it's a direct variation. Here it's tempting to say 9, but the actual true answer is 1/9. As it's y equals 1 over x multiplied by 1 over 9. Direct variation with the constant of variation being 3/5. Inverse variation with the constant of variation being 15. Okay, so we are to solve each problem involving direct or inverse variation. Here, if y varies directly as x, that means, by the way, that's a way of saying y equals kx. And as y equals 6, x equals 15, so put 6 in there, k there, 15 there. And then find the constant of variation, so here k equals 6 over 15. Common factor of 3, so 2 over 5. And then we have to find out what y is when k is equal to 2. So y equals 2/5. of x. And so when x is 2, y is equal to 4/5. Here, y varies inversely as x, so y equals k over x. And when y is equal to 8, x is equal to 5. So 8 there, k there, 5 there. And we're to find out what y is when x is 4. So this implies that k is equal to 40, as 40 over 5 is equal to 8. So put that back in the original. And now you need to find out what y is when x is equal to 4. So just do y equals 40 over 4. And 40 over 4 is indeed 10. Here, if y varies directly as x and y equals 5 when x equals 4, find y when x equals 8. So because it varies directly, and all we've done is just double x, then y would have to be 10, regardless of what the constant of direct variation is. If y varies directly as x squared, that's a way of saying y equals kx squared, and y equals 10 when x equals 2, so 10 equals k times 2 squared. Find y when x equals 3. So this here implies that k is... So rewrite the original relationship, y equals 5 over 2x squared, and then put in 3, 5 over 2 times 9, that's the square of 3, so 45 over 2, so y is equal to 22.5. If y varies inversely as x, so y equals k over x, and y equals 9 when x equals 10, so 9 equals k over 10. Find y when x is equal to 5. So this here implies that k is equal to 90. And we need to find y when x is equal to 5. So y equals 90 over x. And put in there now 5. So y equals 90 over 5, which is 18. Here y varies inversely as x, so y equals k over x. And y equals 4 when x is equal to 12. And we need to find y when x is equal to 2. So this here implies that k is equal to 48. 4 times 12 is 48. And so rewrite the original, y equals 48 over x. And now find y when x is equal to 2, so y is equal to 48 over 2, which is 24. Y varies inversely as x, so y equals k over x. And y is equal to 3 when x is equal to 21, so 3 equals k over 21. So k is equal to 63. So rewrite the original, y equals 63 over x. And now we need to find y when x is equal to 9, so y equals 63 over 9, which is 7. Y varies inversely with x squared, y equals k over x squared. And y is equal to 11/4 when x is equal to 4. So k over 4 squared. 4 squared is 16, write that. And now to find k. That's 11 over 4 times 16. So that's 16 times 11 over 4. 16 and 4 cancel, the top and the bottom cancel, so it's really 4 times 11, so k is equal to 44. And we need to find y when x is equal to 2. So rewrite the original. Input 2. So that's 44 over 4, so 11. If y varies directly as x, so y equals kx, and y is equal to 10 when x equals 20, So 10 equals k times 20, which implies that k is a half, or 0.5. So y equals 0.5x. We need to find y when x is equal to 3. So 0.5 times 3, which is 1.5. If y varies directly as x, y equals kx. And y equals 4 when x is 6. So 4 equals 6k. Find y when x is equal to 5. So this implies that k is equal to 2/3. So y equals 2/3 of x. We need to find y when x is equal to 5. So y equals 2/3 of 5, which is 10/3, or 3 1/3. Finished. Next. Looking at planes. Okay. When an equation sort of looks like this, ax at by at cy, ax at by at cz equals d, where a, b, and c, a, b, c, d are numbers, like 2x at 3y at 4z equals 5. This here creates what's called a plane. You can think of 3D space as sort of like divided up into x, y, and z axes, and then a plane is sort of like, you know, a flat piece of paper but extended infinitely in all directions. And so a plane might be depicted like that because we can only depict a portion of the plane at any one given time. Okay? And what this is asking you to do is find out where it crosses the x-axis, the y-axis, and the z-axis. So to do that, let's think. When it crosses the, if we put in 0 for y and z, then that's where it will cross the x-axis, because any point that lies on the x-axis has a y-coordinate of 0 and an x-coordinate and a z-coordinate of 0. So for x, negative 12x equals negative 48. So x is equal to 4. So the x-intercept is 4, and another way to put that is 4, 0, 0. And for the y, negative 16y equals negative 48. So y is equal to 3. So 0, 3, 0. And for the z-axis, same story. Negative 16z equals negative 48. So z is equal to 3. So 0, 0, 3. We'll just check. 4 through 3. Okay. Okay, so for this one, 2x equals negative 4. So x is negative 2, so negative 2, 0, 0. Same. put in 0 for the y and z. So negative x equals 2, so x equals negative 2. And here. Yeah, so let me just generalize. The axial intercepts of the plane. X-intercept, y-intercept, z-intercept. Now to sketch each plane. So if I just divide everything by 4, that's a start. Negative 2x of 3y take 3z equals 6. And then I find their intercepts. Like that. So do that. Like that. Yeah. Okay. Okay, so divide everything by 2. So 2x of 3. No, wrong. 7, 0 for the other two. So 4x equals 12. So x equals 3. So 3, 0, 0 for the x-intercept. For the y-intercept, 6y equals 12. So y equals 2. So 0, 2, 0. For the z-intercept, 3z equals 12. So 0, 0, 4. And 3 along the x-axis. 2 along the y-axis, 4 along the z-axis. Join them up now with a ruler. And shade it in. Find the intercepts. For the x-intercept, 3x equals 6, so x equals 6 over 3, so x equals 2, so 2, 0, 0 for the x-intercept. For the y-intercept, negative 2y equals 6, so y equals 6 over negative 2, so y equals negative 3, so 0, negative 3, 0. And for the z-intercept, 3z equals 6, so z equals 6 over 3, so z equals 2, so 0, 0, 2, like that. And then 2 along there for x, 3 back for y, 2 there for z. Draw the triangle cutout. Shade. Find the x, y, and z intercepts. So negative 3x equals negative 6, so x equals 2. So 2, 0, 0. 2y equals negative 6, so y equals negative 3, so 0, negative 3, 0. Negative 2z equals negative 6, so z equals 3, so 0, 0, 3. And plot. And connect. And shade. Sketch each plane and write the equation of each trace. So for sketching each plane, that's the same as before. 3, 0, 0, 0. 0, 3, 0. 0, 0, negative 3. 3 along. 3 along. 3 down. Okay.